Hi, in this video we will look at logic gates. Logic gates are the fundamental building blocks in digital electronics. They are used to perform various logical operations based on the inputs that are provided to them. And they give a logical output which can be either high or low, that is 1 or 0. By combining these different logic gates, complex operations can be performed, and circuits like flip-flops, counters, processors, etc. are designed. And we find the application of these logic gates in everyday applications like telephones, phones, laptops, desktops, memory devices, etc. There are a total of 7 basic logic gates, out of which AND, OR, and NOT are called as basic logic gates. NAND and NOR are called as universal gates. They are called universal because any basic gate can be derived using these logic gates. And XOR and XNOR, which are derived from the basic logic gates. Let's look at these one by one. AND gate. It is used to perform multiplication of the binary input, and the output state of the AND gate will be high only when both the inputs are high. It can be seen from the truth table that the output is 1 only when both the inputs are 1. Rest all the cases it is 0. It can be expressed as a function of two inputs x and y as a multiplication. So it mimics the multiplication operation. It can accept more than two inputs and one output at a time. Coming to OR gate, it's most widely used digital logic circuit, and the output state of the OR gate will be high if either of those inputs are high. It mimics the addition operation, and can also have multiple inputs like more than two inputs at once. Coming to NOT gate. NOT gate is like the inverse operation. So it gives the exact opposite of the input. That is, if the input is 0, the output is 1. And if the output is 0, the input is 1. So it is the complement operation, and it will have one input at a time. Coming to NOR gate. So NOR gate is a type of universal logic gate, as already mentioned. It can take two or more input and it gives only one output. The output state of the NOR gate will be high only when all the inputs are low. That is, only when both the inputs are 0, the output is high. Rest all the cases, the output is low. So it is like an OR gate followed by a NOT gate. So you can see it is the complement of whatever the OR operation is. NAND gate, which is another type of universal logic gate. It can be seen like it is an AND gate followed by a NOT gate. So it gives exact opposite output of what a normal AND gate gives. So if it its output is low only when both the inputs are high. Rest all the cases its output is 1. So this is exactly opposite of AND gate. And it can take multiple inputs like more than two inputs and single output at any time. XOR gate is one of the specially designed logic gates that utilizes all the basic gates, that is AND, OR and NOT. It can be seen from the equation that it has all the three basic gates involved, that is multiplication, addition and the complement. So here the output of the XOR gate is high only when the inputs are dissimilar. That means they are not the same. It can be seen that only when the input is 0 1 or 1 0, the output is high. Rest all cases it is 0. It has various applications like it is used in logical comparators, it is used in array detection circuits and etc. XNOR gate or exclusive NOR gate is an exact opposite of what the XOR gate does. That is, its output is high only when the inputs are similar, and when the inputs are dissimilar, the output is 0. And it can take only two inputs at a time, giving one output. Both XOR and XNOR gates can take only two inputs at a time. This is the summary of all the logic gates that have been explained with their graphic symbol, algebraic function and the truth table. Thank you.